Since my teenager years, I've been always fascinated by biology and engineering. So I went to do a master at the University of Twente because it's well known that this university is well recognized for organ-on-chip development. And here I combined the expertise of two different labs, the Amber lab that does organ-on-chip and the DBE group that does cartilage. And by combining these two expertise, we tried to create a model that was able to reduce the animal testing for osteoarthritis. I decided to focus on rheumatologic disease because both my grandparents from the mother's side had this problem, and I see progressively that this problem was causing them pain. And the problem is that we don't have an actual solution, so we can't have a cure for it. And we can see that the people that are affected by it are suffering and they can't do anything about it. There are currently two different techniques to study osteoarthritis, the animal models and the in vitro models. Regarding the animal models, they are really complex, but they are not able to replicate fully what is actually a human knee. And at the same time, the in vitro models are really not complex enough to reproduce what we actually have. And because of this, we don't have a solution regarding drug therapy because we don't have a model that can represent our human physiology. When we are doing an experimentation on an animal regarding this disease, what we have to do is to procure the disease inside the animal. So we are actually causing the pain in the animal for several months, and then after that we try to treat this disease with a drug that probably will not work. And would you find it really ethical? Like if someone would do something like that to you, I think it's completely unethical. And that's why we wanted to create this joint-on-chip, so to combine the advantages of the both fields, so animal models and in vitro models, and at the same time reducing these disadvantages and this ethical concern. These microsystems are designed to recreate the specific features inside the organ, so the size, the shape, the biochemical stimuli, and the biomechanical stimuli, using human cells, so more reliable system. If we look at the joint of our knee, the cartilage within this joint has a specific 3D architecture, but most importantly, there is movement in our joint, and this is a key component for the articular cartilage. So our aim was to recreate the key characteristic of the cartilage, so the 3D structure, the mechanical stimulation, so this kind of compression, but also this shear stress, this sliding effect. Then we wanted to recreate a system that was able to mimic the healthy, but also the disease condition. So for example, too much mechanical stimulation or an inflammatory situation. So the production of this organ-on-chip is not the easiest one. So we need specialized facilities, such as the clean room, where we are able to create our molds. Currently, we have fully characterized the platform, and we are working towards recreation of these physiological and hyperphysiological conditions, so really disease mechanical stimulation. And we are also recreating this native articular cartilage by using this combination of mechanical stimulation, so just by compressing and at the same time also sliding force. And we see that this effect, this combination of effect can enhance the protein production of these chondrocytes, recreating what is actually seen in natural cartilage. So as we are able to recreate this quasi-native articular cartilage, our idea now is to combine it with the other two systems, so the synovial membrane and the bone unit, and together recreate this kind of a joint-on-chip system, which will enable us to create a more natural joint, but external from the joint itself. So this system could not only be used for answering biological questions, but we can also use it as a milestone to create personalized medicine. We're actually in contact at the moment with specific companies that are developing drugs toward treating this osteoarthritic disease, and we are trying to combine these drugs together with our platform. So our mission is to create a platform that can be used not only in the Netherlands but also in the world, and this platform could be used to solve this rheumatologic disease. So there is still a lot of work to do, but I have a great team behind me. We want to have a platform that will be able to create drugs that will help people. but also reduce the animal testing.